right, so now 5.8, we start with linear inequalities. So this time we're just going to deal with a linear inequality instead of a system of inequalities, linear inequalities. That'll be tomorrow. So what is a linear inequality? It's similar to a linear equation. This should be linear equation, I'm sorry. But uses an inequality symbol. Okay, so a linear equation, let's say, is ax plus by equals c, right? That's a linear equation. A linear inequality would have an inequality sign here instead. So that's the only difference. So what is a solution to a linear inequality? A solution would be all the ordered pairs that make the inequality true. Okay, so there's only one value that makes an equation true. There's an infinite amount of values that make an inequality true. Remember, the prefix in means not, like incomplete, not complete. Incapable, not capable. Inequality means not equal. So there's going to be an infinite amount of values that make something not equal, right? So that is what an inequality is. Okay, so here we've got this inequality, right? This is a linear inequality. It's like an equation. If there was an equal sign here, it would be an equation, but we have that inequality sign, so it's an inequality. So we want to know which of these points make the inequality true. Okay, so 2 is my x coordinate, so we're going to plug it in for x. 5 is my y coordinate, so we're going to plug it in right here. So we want to know which of these points make it true. So second quit, clear. So is 2 times 2 minus 3 times 5 less than 15? Yes, it is. Negative 11 is less than 15. So yes. Guys, I'm sorry. I don't know why I put this here. This should be a negative 1, and this should be a negative 7. What was I doing? So a trick that you can do with your graphing calculator is you hit the up button until it highlights the equation. Then you hit enter and it copies and pastes it down here. So right here, I want to put a negative 1. All right, and delete that. And then right here, I want to put a negative 7. Is it less than 15? No. 19 is greater than 15, so this doesn't work. So no. So can you guys please do these two problems right here? Okay. So what you guys are going to do is 3 and negative 4 and 0 and 0. Okay? So 2 times 3 is 6. Negative 3 times negative 4 is 12, so positive 12. Is that less than 15? No. 18 is not less than 15, so no. 2 times 0 is 0, minus 3 times 0 is 0. Is that less than 15? Is 0 less than 15? Yes. Okay? So how do you graph a linear inequality? So graphing a linear equality is a way to show that all the ordered pairs to the solutions. And here is how you do it. So the first step is always write it in slope-intercept form. That's y equals mx plus b. Remember, this is very similar to what we did with solving linear inequalities. Whenever you divide or multiply by a negative number, you flip the inequality symbol. So don't forget to do that. If you do that at any point, I'll show you some examples on that. So then you graph your line. If you have an inequality symbol with this equal sign underneath it, you make a solid line. If you don't have that symbol, if it's just less than or greater than, you use a dotted line. I'm going to show all of this to you in a moment. Then, if you have a greater than or equal to symbol, you shade above the line. Or if you have a less than or equal to symbol, you shade below the line. So let me show this to you in action. So subtract the x term, divide by the coefficient of y. So I just divided by a -3. So that means that I flip this symbol. Okay? So then my slope would be a positive 2/3 x, and my y-intercept would be a -5. Okay? So now we plot our line. So you start with your -5 y-intercept, 1, 2, 3, 4, 5. And then my slope is positive 2/3, so up 2 over 3. 2 points make a line. But because there is no equal to sign here, right here, I'm going to use a dotted line. Okay. Now, it says up here that if you have y is greater than or equal to, you shade above. So that means that I would shade above here. That is one method to show this. I always like to test the point 0, 0. That's another method to show. So is 0 greater than 2/3 times 0 minus 5? So is 0 greater than -5? Yes. So if 0, 0 makes it true, you shade towards 0, 0. That's another method that you can use. Let me show you a couple more examples. Okay, so y is greater than 1/3 x minus 5. So this is already in y equals mx plus b. So my y-intercept is -5, 1, 2, 3, 4, 5, and then my slope is 1/3. So up 1 over 3. Then dotted line. Okay, so then y is greater than. So that means I shade towards, or I shade above the line. Another way that you could do this is by testing 0, 0. Is 0 greater than 0 minus 5? It sure is, so you shade towards 0, 0. So can you please do 2 for me right now? Okay, y-intercept is -1. Slope is -2, so down 2 over 1. Now this has an equal to sign here, so this is going to be a bold line. Okay, now this is a less than symbol, so that they said shade below the line, so we would shade on this side. Another way that you could do this is test 0, 0. If 0, 0 makes it true, you shade towards 0, 0. If it makes it false, you shade away. So if I plug in 0 here, I get 0 less than or equal to 0 minus 1. Is 0 less than -1? No. So you shade away. Okay? All right, number 3. Subtract the x term, divide by the coefficient of y. So because I divide by -2, I've got to flip this sign. Slope would be 5 over 2x. Y-intercept would be -6. So down 6. 1, 2, 3, 4, 5, 6. And then you go up 5 over 2. 2 points make a line. Now, there's no equal to sign here, so this is going to be dotted. This is also less than, so we shade away or shade below the line. Okay? Another way that you can do this is by plugging in 0, 0. I'm going to plug it into the original because 0 minus 0 is 0. Is 0 greater than 12? No. So you shade away from 0, 0. All right. Can you guys please do for me 4 and 5? Okay. Subtract the x term, divide by the coefficient of y. because we're dividing by a negative, we flip our sign. So this will be greater than now. So my slope is 1/4 x. My y-intercept is -2. Up 1/4. We shade above. Oh, it's going to be a dotted. And we shade above. Okay. We can also test 0, 0. Is 0 minus 0 less than 8? Sure is. So you shade towards 0, 0. 8. Subtract the x term, divide by the coefficient of y. Because we divided by y, negative, we switch a sign. All right, so my slope here would be -1 divided by -1, which is 1. And my y-intercept is -8. And then go up 1/1, up 1/1. We're going to have a bold line. And then we shade away, because this is a less than. You shade below the line. Another way that you could do it is test 0, 0. So if we plug in 0 and 0 here, is 0 minus 0 greater than 8? No. So you shade away from 0, 0. Okay, here we go. Subtract the x term, divide by the coefficient of y. So this is a +2, so I don't have to switch my sign. Okay. My slope would be a -3/2x. And my y-intercept would be 0, because 0 divided by 2 is 0. So you start at 0, 0. You go down 3/2. Dotted line. So here's an example of 0, 0 is on the line. So we can't test 0, 0. We could test 1, 1. So 3 times 1 is 3. 2 times 1 is 2. 3 plus 2 is 5. Is 5 less than 0? No. So we're going to shade away from 1, 1. So under the line, which is what we learned originally. If it's less than here, you shade below the line. Okay. So what happens for y equals and x equals? Well, I know y equals means a horizontal line, because all my y's are in common. So 1, 2, 3, 4. That would be my y-intercept. It's going to be a horizontal line. We're going to have it bold or solid because of the equal to sign. So we shade below because of this less than sign. You can also test 0 in here. Is 0 less than -4? No. So we shade away from 0, 0. This right here would be a vertical line. X is greater than 7. So 1, 2, 3, 4, 5, 6, 7. I think that's right. Dotted line. And is 0 greater than 7? No. So you shade away. So above, away. Okay. I tested 0, 0. 0 is not greater than 7, so I shaded away from 0, 0. Okay. All right.